Automotive software is obviously extremely important, but open source software is oftentimes a challenge in this environment. So could you tell us a little bit about the effort that's going on with the Eclipse Foundation and how you've become involved and why it's important?
Sure. Well, thank you first for having us here today. Appreciate it. Automotive software is very important, especially as we have more automation coming in our vehicles. And so a couple of years ago, Eclipse Foundation started working and brought together some people and started the software-defined vehicle working group, which was a group of people coming together to say, how do we start working in open about software? Let's take a step back. Open, why? Well, because open source has been historically proven to be a better model for the collaboration of great creativity with great content. And so the question that has been asked to the community is, how do we actually take that and bring that to a safe Serena? And by doing that, that's where that came from. We're Codethink. We do open source. We do automotive. We looked at that opportunity and said it made sense for us to join and to start participating.
Okay. Now, what are some of the challenges to get something like this into an automotive space, for example, where you do need various certifications? You know, it's something where oftentimes companies will take open source software, do all their certifications, essentially lock it down. But this is a much more ambitious effort.
Yeah, so part of our journey was that the model of the safety model was incongruent to the open source model. The open source model is transparent, open, collaborative. The safety model is closed, confidential, contractual. And so one of the things we, as Codethink, began to recognize is there was an opportunity to start saying, okay, how do we actually start showing value propositions to being able to use open source in safety critical arenas? This journey has been one that we've been on in part with many others, but it's been on for about 8 years. We've come to understand a few different things. And part of it comes down to, we don't necessarily think we can say it's safe software. It should be trustable, meaning I trust this software within this very context of what it's going to do. So our journey has now yielded where we're at with a trustable software framework that we say we can offer software as trustable if and only if we can provide evidence of a number of different tenets. And what we're doing as Codethink and now going into open is taking all those tenets, the tooling, the information, the frameworks, the metrics, the understanding, putting it in open, and then continuing to work on it in open.
Okay. Now, open source software covers a wide range of areas, and there's different kinds. Linux, for example, comes to mind. How do you pick and choose? Are you trying to make this work for all open source, or are you focusing on particular areas that people are going to be interested in?
So the Trustable Software Framework itself is a construct that we believe is necessary that you then be able to make certain claims of assertions against any body of software, specifically big bodies of software, and with a very specific opportunity in open source. It's not that we're saying all open source is safe or trustable. It's that we're saying here's a framework that you can apply in a rigorous manner to be able to understand in an engineering way deeply whether or not I can assign a confidence factor and trust a piece of software. For us, in starting this journey, we are beginning with Linux specifically because so much of what people are looking for is a safe Linux or a safe operating system. And so we're definitely starting with the idea of a safe or trustable Linux. But this is possible for Zephyr, it's possible for proprietary software. Any body of software with significantly large, I mean, you work with a small body, but significantly large, millions, hundreds of millions of lines of code, it's just not possible to use the traditional methods to arrive to some confidence level that this, in fact, is something that I'm willing to actually put on the road or put in the space or put under the water, but more importantly, put in a place where my kids would be sleeping underneath it, like the sleeping under the bridge concept. It's just not possible today with the kinds of software that we're talking about and the kinds of hardware, the microprocessors that we're talking about.
Okay. Now, how does this map to requirements like ISO 26262, getting ASIL D type certification? Part of those include processes that talk about the development tools, the development process that you employ, and then the code itself. Likewise, on large projects, we're talking about Linux. It's not just the kernel, but there's also device drivers and other things that are going to come into play, which are also typically open source. So, you know, where do we mark these things, and how do we now have to incorporate that into the overall development and certification process?
So taking a step back for us, first off, we're not saying that we're going to make a trustable claim, for example, to a safety element out of context, which is one of the approaches. Yeah. Linux, for example, a statement, Linux is safe in any context. That's not what we're trying to do. We're trying to say we can prove to a sufficient degree of evidence and confidence that in this use, it is trustable, it will do what it's going to do, it won't do what it's not supposed to do, and we have confidence that it won't harm. And so when we take a step back and how does that map to, for example, specifically you said 26262, it's important to note that 26262 is the evolution of a bunch of very well-intended automotive engineers who started in the early 2000s with microprocessors or microcontrollers with thousands of lines of code. When the first standard came out in 2010, that was the state of the art. Today, 2024, we are currently looking at products on the field that have up to 8 cores, our L1, L2 caches of multiple millions of lines of code. 26262 presumes that software is deterministic. We know that software at the scale that we're talking about and on the hardware we're talking about is not deterministic. And so we are challenging the assumption that 262 is an appropriate tool for the kinds of software we want. And so instead we're looking at 61508, which is the parent, which basically says we know that hardware is not deterministic, so we have statistical methods that have to be used to try and test and understand it. And we are trying to bring that same level of engineering into software. So be able to start saying with confidence, we have tested, we understand, we know where things fail, we understand how to measure it, and that we're confident in that our measure. So it's a very similar approach to doing hardware, but now doing the software at scale.
Okay. Well, let's talk a little bit about what Codethink does and how they deal with their customers, because I think that, bringing that open source into their space is also something that in the future, we're talking about something that's going to be trusted, is going to be also part of the process. So if people can understand how open source software can fit into their development environment, they'll have a better idea on how they can trust it in the future.
Sure. So Codethink's a Manchester, UK-based company founded in 2007, and open source has been at its core ever since the beginning. With a little bit of tongue-in-cheek, we argue that we provide software genius. Not that we're necessarily software genius, but that we're providing you, the customer, the ability to have software genius, to have a software understanding. And part of that is predicated on the fact that it's open source. So we can teach you, we can talk to you, we can show it to you. And then more importantly, we can teach you and show you how to change it or modify it in specific ways for what you need to do. We can do it for you. But then we can show you how to do it and then be able to say, yes, this is what I wanted, this is what I can trust. That journey now today, 17 years later, has yielded us into this idea of this trustable software framework where we've now embodied the years of the experience, the years of the work, and go back to customers saying, here's everything we've ever done in a package that's consumable to you. It is both products, solutions coupled together, and it's yours. It's yours. Happy to run it for you, happy to develop it for you, happy to continue to manage it for you, happy to be on that journey with you. Whenever you get in time when you're ready to hit the big red button, we're happy to leave and happy to leave it with you. Nothing we do is proprietary in that way, and nothing we do is intended to lock you into us or lock you into a particular solution. So for us, transparency, honesty, telling you what you need to hear, not what you want to hear. Those are sort of the hallmarks of what Codethink does and why our customers continue to come back to us.
Okay. Well, obviously you have some customers that may be starting out with open source already, may be familiar with it, but I suspect a large number, at least initially, were those that are dealing with closed source development. How did they get convinced to incorporate open source? And what kind of challenges did you find in convincing them, or for people in the organization to convince the higher ups that this is a good idea?
It's a never-ending journey. So we're not there yet, I don't think, in its entirety. What happens is there's open source everywhere, and when you start digging into it and you start asking people, do you know X or do you know Y? We're able to point out to places where open source is at and where collaboration models work. Where it gets really sort of interesting is, you're right, in the traditional way of safety and the belief, you can't do this because of this either model or, I'm only used to being able to have claims and liability in a certain particular way. And so what we find is it's a couple different things. One is, and it's especially about the maturity of the company, if you're going to own this, so one of the things, especially in automotive, is so much interest on being an SDV or software-defined vehicle. Understanding that if you're actually gonna own it, then there's a bunch of different things that you have to be considerate about and thinking about that you don't normally or haven't normally considered. And one of them is the software provenance and the software inventory, and then the requirement as a company to be able to actually deliver that software consistently for years to come. We had the pleasure of talking to a heavy industrial company on the show floor, and they were very proud of their very robust inventory. Like, we know exactly the mean time between failure. We have all these spare parts. We're so good. Mm-hmm. And so many of the parts don't have software in them. So one of our lead guys turns around and says, so this component, if you have to pull it out of inventory in 6 years' time, how do you know that the software on it will actually work? And that caused a complete pause. And all of a sudden it was like, oh, that's a good question. Mm-hmm. And so for us, it's always about the software genius sort of tongue-in-cheek comment was, we want to make you smarter about software. Mm-hmm. And in making you smarter, show you how you can do it, and then show you how you can leverage others to help you do it and do it in this open way.